Okay. Oh, this is the Mars is excellent.
So hop dosing and spice roasting vessels. So H1, bittering hops, medium oil. H2, sort of not used all that much. H3 and then H4. This is a Steinecker system. It's German. We made Belgian beers when we bought it. That was awesome. But now we make a lot of really hoppy beers. And filling up these vessels. And then we also, add sugar for higher ABV runoff. So we've actually had to work really hard on making. I mean, these look huge, but to make them work for making any hoppy beer, as well as a new for dry hopping system. But I'll show you that. Hey, way to go! Earth made a big catch today. Earth made a big catch today. I flew off. I mean, honestly, I would not have noticed. I wouldn't have noticed with all the construction. I would have been like,
well, kind of standing right here.
okay.
No, I got it.
All right, good job.
I'm on duty. Good.
It's pretty amazing. You think you can hear you, you're wrong. What?
Sorry. Before we take all our samples of all our runnings, but this is our handheld densitometer. This thing's pretty badass.
It's not a barometer?
It's a hydrometer, a refractometer, a densitometer. So it knows vibrations that go through here. So we start to take samples of first runnings, last runnings. It is pretty badass. It is also way more expensive than it looks.
Broncos won.
Sugar. Hop. Hop extra.
Pure cane sugar. Hop extra.
That's again, lots of.
And when I started here, the hop cooler was where we stored all our hops. We maybe had some of our battery hops currently are targets in what we call the Dominion, which is our warehouse. This is currently about 3 to 4 days worth of hops. Right now, this is probably 2 days of hops. They need to stock it back up. So it's just kind of one of those really cool things. Just show you how growth happens around here. It's not usually all that organic. Hopefully with Asheville, we've learned a lot, and so.
Thank you, sir.
We saw these. These guys are all from Lone Rider Brewing.
Well. Are we going to the guys?
Three and a half months of work full-time microbiologists here. So we have 4 labs that kind of all fall underneath the umbrella of quality assurance. We've got our sensory lab, chemistry lab, microbiology lab, and then we've got our instrumentation lab. Basically what we're doing in here is it's kind of a two-part lab, contamination detection and then yeast propagation. So obviously what we're doing is anything after the hot side, once it goes into fermentation, we're going to grab samples of beer. Every time we move beer, blend it together, we're going to grab a sample of it to make sure that we haven't picked up any kind of a microorganism along the way that's going to eat the sugars and produce off flavors. You know, the two major types we're looking for are Lactobacillus brevis and Pediococcus staphylococcus. Lacto producing the lactic acid souring and Pediococcus producing the diacetyl. We do traditional spread and streak plating for micro. On the earlier stuff, it's going to be more yeast heavy. For anything later on, cold transfer stuff that's gone through the centrifuge or filter, we'll actually run on a microfiltration. Just put it through a 0.45 micron filter paper, capture pretty much anything that's living in there. We'll put it on different types of media to promote the growth that we're looking for. One of the hardest things, and I was just telling Nick about it, was you know, people want answers about microorganisms yesterday, and it takes 7 days to grow beer spoiling bacteria. So we're always trying to improve. We're always trying to do things a little bit faster. We do have an unbelievable microscope to be able to at least get a first look at how things are. But one of the things we purchased about 5 years ago was this machine back here. And this is called a real-time PCR, or polymerase chain reaction. And basically what we can do with that is buy primers that specify between 23 different beer spoiling microorganisms. And what it'll do is it'll actually go through and give a fluorescent tag to beer spoiling bacterial DNA, replicate it, and then give us a readout of the melting temperature. We're able to actually identify what type of bacteria it is down to the species, if it fits into that 23.
Wow.
And then we can do like an analysis and say, okay, this is the risk behind it, this is what it can do to our beer, this is how it's going to change flavor over shelf life, different stuff like that. So yeah, and that can take that 7-day test down to about, you know, with a small incubation period, like 2 or 3 days. We do still have to rely back on plates because DNA can be living or dead. So, you know, if it's dead DNA, then we're not worried about it. It's not going to affect the flavor or anything like that. So we'll look back at the plates and say, okay, is it actually growing? Is it going to eat sugars and producing off flavors? And then on the propagation side of things, we prop all of our own yeast in-house. We start with slant. We take it and step it up into 200 milliliters of wort, 3 small flasks, beveled flasks, to get that oxygenation in there and get those yeast growing up as much as we can. We'll spin them for about 2 days, and then we'll step them up into a liter of wort, 3-liter flasks. We'll spin that for a day, then we'll step it up into a half barrel full of 30 liters, so it's just a slow prop up, and then it'll go into plant propagation. They'll get 3 step ups of plant propagation, and then it'll be ready to one of those fermenters. The whole process takes about a week and a half to go from the slant to fermenting out beer. So
How many generations?
so we'll harvest up to about 8 generations is what we try to cut it off at, just because at that point the yeast gets a little bit tired and you run the risk of contamination. So.
You reject whole batches because of bacteria?
We will if we do. We haven't in a while. You know, the tests that we have in place are good tests, but it's really hard to separate out bacteria from yeast, even by PCR. You know, they've been living together for thousands of years, and it's like, oh, we don't want you to be together anymore. It's a pain in the ass, but we figured out ways to get around it as much as we can, and we're pretty good. You know, we have a really clean system and everything in place. We try to not use hoses as much. We try to use a lot of our hard pipes and stuff like that, which helps.
How often, you've got a huge plant, so how much testing do you do at different points throughout each one of the facilities?
So with our just on the micro side of testing, we'll probably test a beer 5 times throughout the life of the beer in process, and then we'll obviously grab a bright tank sample and then a finished product sample. We grab a finished product sample every batch that we do at different points throughout the run as well. So yeah, just to make sure that, you know, okay, at the start it was clean, in the middle it was clean, okay, it got dirty at the end. What happened? Was it a filler? Was it something in the tank? Something like that. You know, we always want to just be able to pinpoint it. You know.
They also pick up airborne stuff too.
So we do test air quality throughout the brewery. We will on some of our medias pick up a little bit of air stuff, but you know, a lot of our testing and the real critical stuff is done in this Lambert flow hood. So basically, it runs air down through a filter and blows sterile air out, so then that whole environment's sterile. So then we know, like, okay, if it's clean, if we do see molds or different stuff, it's coming from the tank, and that's kind of a red flag to say, hey, if this stuff's growing there, you know, a beer spoiling organism can grow there just as easily. So.
Thank you so
Very
much.
cool.
Yeah.
I feel like being a troubleshooter.
Thank you.
Oh, it's just coming in.
What are you doing?
Microbiology.
Just use the last spot.
All right, chemistry on next. So real quick, because I end up skipping over it, about the process water treatment facility. So the process water treatment facility is back on the southeast corner of our property. It's a series of ponds, anaerobic and aerobic, that have microorganisms that basically, eat all the bad stuff and fart out methane gas. We have 2 bubbles like this out back, which is, well, maybe sort of this time of year, leaves are falling off, that you'll see. So we harness them into those bubbles and we bring them back into a generator. It's a very uncool looking thing. It was back in the brew house, but it's a 500 watt generator. And then we also have a 250 watt generator out at our process water.